Today I'm talking about LeetCode problem 62, unique paths. What this problem asks is it asks you to write a function that, when given an m and an n that describe a grid, m being the width of the grid, n being the height, it asks you, given this grid, and assuming you have a robot starting at the upper left-hand corner of the grid, how many unique ways are there for the robot to reach the finish point if the robot can only move down and to the right? So what I did first is I started, kind of drawing or looking at this problem and trying to work that out myself. So just starting from the end point, I thought, there's really 0 ways if you're at the end to reach it. I later came to think of this as 1 way. And then I just tried to work out for myself how many ways are there to reach the end if you're, right next to the end. And then since the robot can only go down and to the right, how many ways are there to reach the end if, say, you were here? Well, there's just 1 way, and there's just 1 way. And then if you're above or to the left of a space that has 1 way to reach the end, you basically have 1 way to reach the end. If you can only go right to reach a spot that has 1 way to reach the end, then you only have 1 way. How you get multiple paths, how you increase your value above 1 way is basically if you have 2. Like if you can choose if either right or down will take you to the end, then you have multiple ways to get to the end. So basically what this is saying is if you start at 1, so if we were going to draw like our 3x2 grid, if you start at the end point, and the end point we'll just say has a value of 1, then when we want to fill in the adjacent cells, we fill them in by summing the values that you're adjacent to. So in other words, this is 1, it's only adjacent to a 1. Then we can fill this one in, it's a 1, it's only adjacent to 1. Now we can fill this guy in. I don't know why I wrote a 0 there. I meant that to be more like a circle highlighting which guy I'm talking about. We can fill this guy in. It's a sum of his 2 neighbors. So 2. Then this is 2. No, sorry. This one is 1, and this guy is 3 because he can go either right or down. So you could go right, down, right. You could go right, right, down. You could go down, right, right. So you have 3 neighbors. And then how I chose to solve this, once I had that realization or had that understanding, I solved one other one myself on the grid, just kind of because it was fun to solve on the grid like that. What I did is I solved this recursively. So I'm just using my helper function robot at, positioning my robot at 1, 1. I'm giving it the m and n coordinates. And what I'm doing for robot at is I am saying, let's set aside this part. This is the memoization part. I'll speak about it at the end. I'm saying if the robot's x coordinate and the robot's y coordinate are equal to the end x and end y coordinate, then I can just return 1. So that's my recursive base case. That's what we're seeing here. The end spot is valued at 1. I initially thought maybe I should value it at 0, but that doesn't work out nearly as nicely. Okay, so my base case is 1. You're at the end. You have 1 path to the end. That's where you are. I initialize right and down. These are separate paths or separate routes to the end. I initialize them both as 0. And then I say if rx plus 1 is less than equal to index, so if the robot's current position pushed 1 to the right is smaller than the end value, then we're going to evaluate this. So this is just a check to say, if the robot's on the far edge, we don't want to consider his rightward motion because that wouldn't make any sense for him to keep going right if he's already on the rightmost edge. And so there what we do is we just recursively call to get the value for right for the robot at one spot to the right. And then we do a very analogous thing with the robot's y position. If that increased by 1 is less than or equal to the end y, then we'll evaluate its downward motion. If the robot's already at the bottom, obviously we don't need to evaluate any additional downward motion for the robot. And so then we just say the result is equal to the sum of the right plus the down. So the same thing I showed you in the diagram, where we're just building out the robot's paths, basically the sum of the paths. I forget where I was showing you that. I don't see anything in progress, but yeah. So the sum of the right and down paths. And so then finally, like I mentioned, I'll just say a thing about memoization. So when I first ran this, it worked on small values. I think I can show my test cases here somehow. When I first ran this, it worked on small values. So like a 3x2 grid or a 7x3 grid it worked on. But when I started to get into values like 15x15, it wound up failing. And the reason for that is this will expand pretty rapidly and require it to have many recursive calls. So if we just imagine this, let's see how quick this expands. These are 1, this is 2, this is 1, this is 3, this is 1, 3, this is 6. Okay, I think it's not going to be clear how quickly this will expand. I didn't do this myself. But anyway, apparently if this grid were 15, 15 by 15, by the time we reached the robot's starting point, these numbers would be very large, but they'd also involve recursively calculating the paths, too many paths, I should say. So when the numbers are very large, that each number, I think, corresponds to a single path that we have to calculate. So I realize I'm not doing a great job of explaining that, but the point is that there are many function calls, basically with the same arguments, that we have to kind of repeatedly make in order to recursively calculate all the different robot paths. And so to save ourselves from having to recalculate essentially similar things over and over again, what I did here is I just stored the arguments to my robot at function into an args tuple, and then I have a robot ats dictionary in my solution object. And so I just say if the args tuple is already in my dictionary, then just return the value for that args tuple. Otherwise, calculate the value as per I just showed you. And then when you're done calculating it, before you return it, store what you calculated in the robot ats dictionary under the args tuple. So that way you don't have to recalculate anything again. And so once that was done, then I was able to calculate even the 15 by 15 grid. I don't know why LeetCode is not calculating for me right now, but I did just submit and solve this problem. So yeah, that's LeetCode problem 62, unique paths. Yeah, feel free to click the like button, leave me a comment, let me know you're watching, and subscribe if you want to see more LeetCode problems. And I'm also interested in the game of life. I've got a video or two about that I'm making right now. Thanks.